This lesson is on distance on the coordinate plane. And I start off by putting why the Pythagorean theorem. You can use the theorem to find the distance between any two objects in space. And the way this is going to work for us is if I have 2 points, those 2 points, this straight line between them, I could figure out how long that is. But to do that, I need to know the vertical and horizontal distances. When I do, this creates for me a right triangle where I can say A, B, and C. So the distance, this red line going from one point to another, happens to be the hypotenuse of this right triangle made by finding the vertical distance and the horizontal distance. We have an equation that goes with that, and we've used this to help us find what one of the missing lengths is. We've used our equation, the Pythagorean theorem, to find A, or to find B, or to find C. And we're going to use that to actually find the distance between points on our coordinate plane. The first type of question we're going to look at is going to ask us to graph the points or the ordered pairs 1, 3 and -2, 4. Then find the distance C between the 2 points. Round to the nearest tenth. When we're trying to find the distance, we're going to be finding the hypotenuse C. The first part, we need to go ahead and graph these. So 1, 3, -2, 4. I'm just going to label them so you see which is which. The distance between them would be the straight line that goes from one point to the other, which I have marked in purple. And we're being told that that distance will be C. Now, in order to find C, we're going to create our right triangle. Our vertical distance, which is one space, and our horizontal distance, which is 3 spaces. So we find that by just counting the number of spaces to get from one point to another. This is very similar to it is like we are counting slope. And in some videos, you will actually hear the person saying just that. That we're using the same count as if we're counting slope. Now we'll place our numbers into the equation and begin solving. We'll make A 1, B will be 3, and we're going to find C. Step 1, evaluate squares. 1 squared is 1, 3 squared is 9, and I don't know what C is yet. Step 2 is our add or subtract step. And in this case, I need to add, so I combine like terms, and 10 equals C squared. To finish, we find the square root. And once we find the square root of 10, we will have our answer. And recall, we're only going to keep the positive. So in this case, the distance between the 2 points would be 3.2 units. We don't know what specific kind of units, so we call the block on the graph units. I'm going to take a look at a couple of examples here, and specifically just the top two. And I just want to pitch the idea of, what if we don't really have a graph to use? Well, we can still figure out the pieces of our right triangle so that we can find the distance. And how this is going to work is, imagine our right triangle. On a graph, remember that y's are the horizontal, the vertical, y's are the vertical, and x's are the horizontal. If I wanted to figure out what the vertical and horizontal distances are, it would be like us finding the slope. The differences in the x's and the differences in the y's. Let's call the distance in the x a, and we would need to do 2 minus -1. And the difference in the y's, we'll call that b, -4 minus 2. And in this case, again, for the right triangle, we have a horizontal and a vertical. And we're saying that A is just the x2 minus x1, and the B is y2 minus y1. This is just as if we found the slope between 2 points. Once we have those pieces, so A is 3 and B is -6, we will say 3 squared plus -6 squared equals C squared. And we can begin using the exact same steps to find C, which will be that distance. Now, we have not seen what happens when a negative is in here. But this first step where we will evaluate the squares, 3 times 3 is 9, -6 times -6 is positive 36. So it really changes nothing in the grand scheme of what we're solving. 9 plus 36 is 45. And then the last step, we will find the square root. Now let me remind you of what we did in this problem. If we are on the coordinate plane, y and x, and we have 2 points, our length here is C. Think about these 2 points as if we were trying to find their slope. From 2 up, or 2 to -1, actually I'm going to go that the other direction. From -1 to 2, that's +3. And that will be our horizontal distance. And from 2 down to -4 is -6. And we can use those pieces, just like when we found slope, to go back and tell us what the distance between the 2 points actually is. Now, this is leading us towards an actual formula that we're going to look at on the next slide. So, to start, we've been doing the Pythagorean theorem. And yes, I still struggle when I spell it. A squared plus B squared equals C squared. Now, our whole goal for finding distance is to solve for C. Let's look at the Pythagorean theorem and let's get C by itself. Well, there actually is a way we could do this from the very beginning. What if we did our square root step here at the beginning? I would end up with C is equal to the square root of A squared plus B squared. This is still the Pythagorean theorem. The only thing that's different is I have put the C by itself. All I would still need to do is put A and B into the equation, and it would solve for C. This is a way of writing what is called the distance formula. And the distance formula is used to tell us how far apart 2 points on a graph are from each other. Because on a graph, most of the time, those points are on a diagonal. And there's no real way for us to count the length of that diagonal, unlike how we can count how far up and down, how far left and right. Well, we can still use that, the how far up and down and the how far left and right, to solve and find the distance. To make this work, we'll make A horizontal change, or horizontal distance, and B the vertical distance. Now, if we go back to when we did slope on a graph, we're looking at an x1, y1, x2, y2. Your horizontal distance is x2 minus x1. Your vertical distance is y2 minus y1. What we're going to do next is we're going to substitute that into our Pythagorean theorem, and it'll look like this. Now, I'm trying to solve for C. And we're saying that C squared is equal to A squared plus B squared. It's still the same, even though I wrote the C on the left. Now, if I substitute the x2 minus x1 for the A and y2 minus y1 for the B, this is how I find what A and B actually are. And then in the very last step, we're going to take that piece and take the square root. Now, I'm going to tell you this. This formula works for some people and not for everyone. Since they are related, I am showing them to you. But in the next example, I'm going to do the problem with both equations. I'm going to show you how to use either the Pythagorean theorem or the distance formula. The only difference is the distance formula will require you to do some work beforehand, whereas the distance formula has it already built in to the equation. And this example is where I'm going to use both of them. On the map, each unit represents 45 miles. West Point, New York, is located at 1.5, 2. And Annapolis, Maryland, is located at -1.5, -1.5. What is the approximate distance between West Point and Annapolis? So I see West Point, New York, 1.5, 2, Annapolis, Maryland, -1.5, -1.5. But what is this each unit represents 45 miles? Well, we'll come back to that. For now, let's figure out how many units apart they each are. First up, Pythagorean theorem. For the Pythagorean theorem, I need to know a couple things. First, A, my horizontal distance. Well, that tells me it's a total of -3. And for B, here I have 3.5. Now, realistically, that is just 3 units and 3.5 units. But let's put those into our Pythagorean theorem. What's great is once we square those, it won't actually matter that they were negative. All right, so step 1, evaluate those squares. 3 squared is 9 plus. All right, well, got to be careful with this next one. Even I'm going to double check my calculator, though I think I know what it is. I would have been wrong. All right, so I'm trying to solve for C. So step 2 means I'm going to add these together. Then take the square root. And again, I only need the positive. Now, I must warn you, this question isn't done. Because this is 4.6 units. So I need to change units into miles. Remember, it says each mile, or each unit, represents 45 miles. Remembering that piece, I need to multiply this by 45 to find my approximate miles. So this was something we had to do in 2 parts. So we cannot forget, yeah, we got our answer, but our answer was in units. And they wanted the answer in miles. And that's what that first chunk was about. Let's see if we get the same thing with the distance formula. The one thing with distance formula I will say is, with the 2 points they gave us, it would be a good idea to label x1, y1, x2, y2. Sometimes you will see the distance formula written with a d instead of a c as the variable. But as we're connecting this to Pythagorean theorem, we'll leave it as c. So x2 minus x1 squared plus y2 minus y1 squared. And I'm actually going to label that just so you see. You wouldn't normally label it. This is me just showing you. We would begin simplifying this as much as we can. I always start with simplifying the subtraction on the inside of the parentheses. We're using the order of operations, and we're going to start with simplifying the inside. Negative 1.5 minus 1.5 is negative 3 squared plus negative 1.5 minus 2 is negative 3.5 We would go next into the squares. Sorry, I'm going to change these colors to differentiate, mainly for when these notes are handed out. So next step inside the parentheses, we're still dealing with, now that the parentheses are simplified, they have exponents on them. So -3 squared is 9 plus -3.5 squared is 12.25 . This square root sign acts as a parenthesis itself, so I still got to simplify what's on the inside. 9 plus 12.25 is 21.25. And this last part here should seem familiar, because to end this, I'm going to take the square root. Now, Pythagorean theorem only gives us units, so we are going to convert this using the fact that 1 unit is 45 miles, so 4.6 units times 45 will give me the 207.4 miles. So it is just completely up to you which method you actually prefer for finding the distance. If you need to see how the distance formula works again, please back this up to when I start that so you can see it in full one more time.